Water, the essence of life. For ages, our great rivers, the Amazon, Nile, Mississippi, Ganges, Yangtze, and others have been our natural fresh and drinkable water source for our life sustenance and food security. However, the capacity of these rivers to meet our water demands has been severely strained by persistent droughts, rapid desertification, and growing populations. On the other hand, oceanic water covers more than 70% of our planet. But we cannot directly utilize oceanic water for essential activities such as farming, irrigation, drinking, and cooking because of its high salinity and impurities. At its core, seawater desalination removes salt and impurities from seawater to produce fresh water. Two leading technologies dominate this field: thermal desalination and membrane desalination. Thermal desalination uses heat to evaporate water, leaving salt behind. This method mimics the natural water cycle but on an industrial scale. Subcategories include multi-stage flash distillation, multiple effect distillation, and supercritical water desalination. Membrane desalination, particularly reverse osmosis, pushes seawater through specialized membranes to filter out salts and impurities. RO is energy efficient and widely used globally. Behind every successful desalination plant project lies a robust and reliable process plant model. These models help in designing, analyzing, optimizing, and developing sustainable desalination systems. At Nubira, we have developed several scalable and detailed desalination plant models, especially for multi-generation plant systems which can generate electricity, heating, cooling, and fresh water concurrently, offering solutions tailored to diverse local needs. These models simulate key processes, from water intake and pre-treatment to desalination and post-treatment. They provide insights into energy consumption, material efficiency, and system integration, enabling more sustainable and cost-effective designs. One of the biggest challenges in desalination is energy consumption. Membrane-based technology use a lot of electricity while thermal technologies need heat. But integrating renewable energy sources such as solar and wind with these desalination technologies are more productive and economical to operate. An integrated desalination system model can be developed where solar thermal energy drives thermal processes during the day, while wind power ensures continuous operation at night. These models can be used to analyze and reduce the desalination technology reliance on fossil fuels and lower the greenhouse gas emissions of desalination plants. Regions like the Middle East, North Africa, and parts of Asia are already leveraging these technologies to transform arid lands into fertile grounds. By scaling these efforts, we address the pressing challenges of our time. The future of desalination lies in continuous innovation. From AI-driven plant operations to advanced materials like graphene membranes, the possibilities are endless. Nubira process designers call for global collaborations with engineers, industries, academics, researchers, students, and individuals around the world in expanding access to desalination technologies and ensuring a sustainable future for all. Water is life. And with desalination powered by renewable energy, we can bring life to even the driest regions of our world. Together, we can turn the tide for a brighter, greener future.